Well, hello. Uh, Now our topic is extraction of roots of complex numbers. So here we have the question, find the square root of a complex number, z is equal to 1 plus, z is equal to 1 plus square root of I. So to find the first thing we have to do is finding the modulus of the complex number. R is equal to modulus of the complex number z. This is equal to the square root of the real part squared plus the imaginary part squared. This is equal to square root of 1 plus 3. This is the square root of 4, which is 2. So R is calculated. Now the next step is to find the argument, theta, okay, which is equal to tan inverse y over x, tan inverse imaginary part divided by the real part. This is equal to tan inverse, okay, tan inverse square root of 3 divided by 1. This is equal to 60 degree, which is equal to pi over 3, okay, pi over 3. Then here we have the formula for finding of the Euler of, let's say, the roots, okay, the nth roots. So the nth root of z is represented as r to the power of 1 over n, times e times I the power of, okay, e the power of I times theta divided by n plus 2, okay, 2k pi divided by again n. This is the formula to find the nth root of n complex number. But here we have to be clear, okay? Here, if this is a square root, then n is 2. But we know that k is always, okay, going from 0, okay, up to n minus 1. In our case, since n is 2, k is, okay, 0, n minus 1, 2 minus 1 is 1, so it grows up to 1. If n has been 5, so k would be 0, 1, 2, 3, 4, because n 5 minus 1 is 4. So our k is 0 and 2, 0 and 1. So using this, we do have the formula ck, okay, ck is equal to now 2 to the power of 1 over n, okay, r is 2, to the power of 1 over n is 1 over 2, okay, 1 over 2, e the power of I times our angle is pi over 3 divided by 2, okay, plus 2k over n is 2 again, the angle is pi over 3. So in general form, okay, ck is equal to 2 to the power of 1 over 2, this is n, square root is 2, okay, 1 divided I times, this is pi over 6 plus 2k pi divided by 6. This is the general form of the square root of any complex number. Good. So now in our case, okay, in our first case, k is equal to 0. So we find the first root, c0. Now c0 is equal to 2 to the power of 1 over 2, okay, e the power of I times pi over 6 plus 2 times 0 times pi divided by 6. Okay, now this part is 0. So c0, the first root when k is 0 is 2 to the power of 1 over 2, e the power of I times pi over 6 is the first root. Okay? So now here, once we have the first root, so we can change this in polar form, okay? In polar form, the equivalent polar form here is this is equal to, this is equal to, now this is equal to, now here r 1 over 2, meaning 2 the power of 1 over 2 is square root of 2 times the angle is, okay, cos the angle here is pi over 6, cos pi over 6 plus I sine pi over 6, okay, I sine pi over 6. Now cos pi over 6 is cos 30, okay, cos 30 is root 3 over 2, so that this is root 2, okay, this is root 3 over 2 plus sine 30 is 30 degree for, okay, 1 over 2, so this is it, 1 over 2. So the product of the two is now square root of 6 divided by 2 plus this is square root of 2 divided by 2i. This is CO, okay? CO. So this is the first square root, one of the square roots. So the second case is when k is 1, okay? K is 1. Now the second situation is when k is equal to 1, okay? K is equal to 1. Then the root is said to be C1 is equal to 2 the power of 1 over 2 times e the power of I times pi over 6 plus 2 times our k is 1 times pi divided by 6. Now this is equal to, okay, this is equal to, now this is 2 pi over 6, this is pi over 6, okay, 2 pi over 6. So 2 the power of 1 over 2, e the power of I, this is pi over 6 plus 2 pi over 6, okay. The sum goes pi over 2, okay, to pi over 2. Now pi over 6, this is 3 pi over 6. This is equal to pi over 2. Pi over 2 is 90 degrees. So this is equivalent to 2 times 1 over 2, e the power of I times pi over 2. Okay, the polar form for this is, again, this is equal to square root of 2 cosine of into cosine of pi over 2 plus I times sine of pi over 2 cosine of pi over 2 plus sine of pi over 2. So root 2 times cosine of pi over 2, now this is 0, cosine of pi over 2 is 0, okay, this is 0, and sine of pi over 2 is 1, so that this is equal to square root of 2 times 0 plus 1 times I, this is 1, okay, so I. So this is equal to square root of 2i, square root of 2i, this is C1. So that here we have the two roots, the first root, okay, the second root. So the roots of this complex number, okay, this complex number are, okay, the roots are the square roots, the square roots of a complex number z, which is equal to 1 plus 3 square root of 3i r, okay, C1, which is equal to square root of 6 divided by 2 plus 1 over 2i, and the other is C2, which is equal to square root of 2r. These are the roots of, okay, the roots of the complex number, the roots of the complex number. Thank you for watching. Do not forget to subscribe, like and share for friends. See you in the other videos. This is Ahatube. Thank you for watching.